Hello everyone, my name is Vera Bhaskar Mutiala. I'm a technical marketing engineer at Cisco for catalyst switching and Cisco smart buildings. In this video, we're going to talk about the catalyst features for PoE resiliency. Ever since 90 watts of PoE power is made available and ratified and RePoE Plus and IEEE 803BT standards, we have seen a rapid adoption of PoE power as a main source of power, alternative to the traditional AC power systems. This PoE power is now powering building management systems, smart lights, point and zoom cameras, laptops, and so on. And this started enabling smart buildings overall. And this makes a point that there is a need for robustness and resiliency in our network design for Power over Ethernet. So there are three important features in catalyst switching hardware and iOS XE that network admins can take into their design. The first one is Perpetual PoE, the second is Fast PoE, and the third one is PoE port priority. So the first one in this list is Perpetual PoE. As the name says, Perpetual PoE is continuously providing power perpetually, even when the switch goes for a maintenance or soft reload. That means if you have a PoE powered endpoint connected to the switch, even if the switch is booting, the PoE powered device such as access points, IP phones, point and zoom security cameras, they stay powered on even when the switch goes for the soft reload. The PoE device will continue to stay powered on the last negotiated power levels. The next one is Fast PoE. Fast PoE is about how fast we recover power onto these PoE powered endpoints if the switch happens to have any unplanned or unexpected power outages. In the case of power outages, as soon as the power gets restored to the switch immediately powers on the PoE endpoints using the previously negotiated power levels and then have them can finish their reboot and stay powered on while the switch finishes its recovery process such as data plane and control plane. This means by the time switch completes its reboot and have this control plane and data plane up for forwarding, the endpoint, the PoE powered endpoint, is ready to forward the traffic. This is done using a PoE plane which is completely separate from control plane and data plane on the Cisco switches. The PoE plane has the data of all the microcontrollers and power controllers and the previously power negotiated values from the endpoints. So this means the switch maintains a database of the operating power values on each switch port, and if any planned or unplanned maintenance happens, the switch always remembers and recovers the power at these ports using those previously saved power values. So what we have here is a Cisco smart building where 9348HX is providing 90 watt of PoE power to these lights. In the first part of the video, without any PoE HA configured on the switch port, we will reload the switch and measure the impact and recovery time for the smart light when the switch goes for a software reload or power outage. In the second part of the demo, we will enable Perpetual PoE on the switch interface and reload the switch with a soft reload command and see the impact on the smart light. And in the third part of the demo, we will enable Fast PoE on the switch port and cause a power outage manually on the switch. And then we will measure what is the recovery time for the smart light once the switch gets the power back on. So here we have a 9348HXN switch. We have 48 ports of PoE power available here. That means 90 watts of power available on each switch port. However, we have one smart light connected on port 1012 that is class 8 negotiated. That means about 90 watts of PoE power has been allocated to this smart light port. And I'll do a show power inline and UPoE command to see what is the current power drawn, which is about 42 watts of power being drawn from the switch port for the smart light that we are seeing on the top right corner of the screen. And here we have the dual power supplies operational. I'm going to pull off one of the power supplies power card, the primary power supply, and we'll do a show power detail command here. and see that the primary power supply, that means the power supply 1, has been removed manually. And I'm going to start the stop clock and then pull off the second power supply as well and recover the power on the switch and turn on the power, the timer, to start counting how many seconds it would take for the switch to recover once it has its power supply recovered. So the power has been recovered on the switch at this stage, and the switch is waiting for the boot up process to begin. Now we see that the switch is doing the install mode boot up process using the packages.conf file, and we see that on the screen here the switch LED lights are showing up that the hardware boot up process is happening right now. So I'm speeding up the time here, so this is about 3 minutes, and switch is about to finish its reload process, and we can still see that the smart light is still powered off. And there you go, it just recovered about 3 minutes and 20 seconds time. So this is about 3+ minutes of outage for the smart light if we are reloading the switch without any Perpetual PoE or Fast PoE enabled on the switch port. Now let's go ahead and configure Perpetual PoE in the switch now. Now let's get to the configuration part here. So let's confirm that we can see the LLDP enabler of this device that being learned by the switch. There is an eager light there. And now let's configure the port configuration on the switch. First I shall turn it off just to show that it's the right switch port that we're operating right now. Then I will turn it back on. We'll see if this light immediately recovers the power. And we're going to configure the port now with Perpetual PoE. The Perpetual PoE also works with stack power. There you go, we have the configuration right now with Perpetual PoE. And Fast PoE. Now I'm going to do a maintenance or planned maintenance outage. That means I'm going to reload the switch with the reload command here. And you can see here that the phone and PoE PC power got disconnected. However, the light stayed on rock solidly. That means the PoE power is going on to the smart light where we have this Perpetual PoE configure, and we're doing a planned maintenance reload. This can be a soft reload, and you can see here the switch system LED lights, and it started booting up, showing that the switch has kicked in into the boot up process. Now let's wait for the switch to complete its reload process. But the good thing what we can see here is there is no outage or impact for the smart light. And I'm doing this reload in a bundle mode here. What it means is even when the switch has to unbundle the image and take a little bit longer than install mode for the boot up process, the switch is still powering on the PoE light as usual without any impact or outage on it. There you go. Now the switch has completed its boot up process, and we can see the ports being recovered now, and we can see the PoE monitor and phone, IP phone as well recovered. But those ports don't have the Perpetual PoE, however the smart light has, so that's the difference there. Now is the part for the Fast PoE. So with Fast PoE and configured on the switch port already, we can see that right now the switch port is pulling about 42 watts of PoE power, and LLDP enabler confirms that there is a detection of the smart light on the switch port. And here is the software controller of the controller software of the light, and I bounced the light just to show that there is a connectivity between the controller, the lighting management controller software, and the switch smart light. You configured Perpetual PoE HA, and I'm also going to configure Fast PoE. There it is. So one thing to remember is Perpetual PoE needs to be enabled on any port that needs Fast PoE. Okay, now we have both Perpetual PoE and Fast PoE configured on the switch port. Now let's do a show power detail to confirm that there are enough power supplies, and I'm going to induce a power outage now using the manual intervention here. So you can see here I'm pulled off the power, and I'm going to start the clock here, and we will count down the timer to see how fast it will or how long it will take for the smart light to recover. Now I recovered the power. As you can see, the LEDs on the switch too, and there you go, the smart light has immediately recovered the power. So that's like a 3 minutes outage window reduced to 3 seconds with Fast PoE. The next one is about PoE port priority. The PoE port priority is about how intelligently the switch sheds the load when there is an outage on primary or secondary power supplies. That means when there is an allocation of power that is more than what the switch is currently available or currently having it using the power from the power supplies, then the switch would shut the load on the PoE endpoints or PoE ports using this load shedding algorithm. That means if a port has been configured at high priority, the port is likely to retain the power. That means in case of a security camera or a badge reader that can be kept at high priority port, that will retain power, while some smart lights or some low priority devices powered on PoE can be kept at low priority power. We hope this video is informative to you, and thank you for watching.